Okay, there's your thought for the day. We're going to cover section 2.2, polygons and circle. Our objectives are to identify polygons and know their characteristics, know parts of a circle, and understand symmetry. Let's define a triangle. A triangle is a figure formed by how many lines?
3.
Good. 3 lines. A triangle has 3 angles and 3 sides. So here's an example of a triangle. I name a triangle with a triangle symbol in front of it, and then the 3 letters, A, B, C. Order of the letters doesn't matter. Equilateral triangle has all 3 sides congruent. The word equilateral, equa means equal, lateral means side. So all 3 sides in a triangle are equilateral triangle are the same. Looks like something like this. I would mark it with tick marks to show that all 3 lines are congruent. Equilateral triangle. Isosceles triangle has at least 2 sides congruent. It can have more, but it has at least 2 sides. Iso means equal, and then the celes is also another word for side, so it has 2 equal sides. And a picture of an isosceles triangle would look like this. These are the 2 equal sides. The side that's not equal to the others is called the base of the isosceles triangle, and then the angles adjacent to the base or next to the base are the base angles. Okay? Questions there? Okay? Scalene triangle. A scalene triangle has no sides congruent. Might look like this. None of the sides are congruent. Well, what do I call a triangle that has all 3 angles less than 90? Anybody know? Yeah?
Acute.
Yep, it's an acute triangle. Acute triangle. That could be an acute triangle. All sides angles less than 90. Right triangle has 1 angle that is a right angle. How many degrees is a right angle? 90. All right. So if we label the picture of a right triangle, the side across from the right angle is the hypotenuse. And then the other 2 sides are legs. All right. Obtuse triangle. An obtuse triangle has 1 angle that is an obtuse angle. Can't have more than 1 obtuse angle in a triangle, then it would measure more than 180 degrees. So there's 1 angle is obtuse in an obtuse triangle. It's a picture of what an obtuse triangle might look like. Okay, we talked about An equilateral triangle is a triangle that has all three sides congruent. What would I call a triangle that has all three angles congruent? Yes?
Equiangular?
Right, it's equiangular. Equiangular triangle has all three sides congruent. Not all three angles congruent. Is an equiangular triangle equilateral? It is. All equilateral triangles are also equiangular. Okay? Simple closed curve. A simple closed curve is a figure that lies in a plane and can be traced so that the starting points and ending points are the same and no part of the curve is crossed or retraced. Let's look at some examples and then we'll look at some things that are not example. So an example would be something like this. That's a simple closed curve. The starting points and end points are the same. It was right here. No part of the curve is crossed or retraced. This could be a simple closed curve. You think of curves as being rounded lines, but according to this definition, this quadrilateral is also a simple closed curve. Some things that are not simple closed curves, all right, we could take this figure 8. That's not a simple closed curve because it crosses, right? The part of the curve crosses. This is not a simple closed curve. We can take something like that. That's not simple closed because this part would be retraced right there. Do I get the idea? Circle is a simple closed curve that consists of the set of all points. What? Equidistant from a given point. All points equidistant from a given point, and the given point is called the center of the circle. What do I call the line segment joined in the center with a point on the circle? What is that? So we're talking about the segment from the center to the circle. What is that? Yes?
Radius.
That's the radius. The radius is a line segment joining the center. The plural is radii, spelled R-A-D-I-I. You're talking about more than one radius. It's radii. Also used to denote the length of the radius.
Mr. Moore,
Yes.
geometry books are in.
All right, thanks. So radius also means a length. It can be the line itself, or it can be the length, right? Radius also represents length, that term. All right. What is a line segment connecting the center with endpoints on containing the center with endpoints on the circle? What would that be called? Yeah, it's your diameter. That's the diameter is a line segment that contains the center and has endpoints on the circle. Also used to note the length of the diameter. Diameter also can be a length. So that line is the diameter, this is the radius, and this is circle O. Everybody have it? Alright, so a polygon is a simple closed curve composed of line segments. Adjacent vertices share a common side, so the vertices next to each other in the shape share a common side, and adjacent sides share a common vertex. Right? Everybody have it? Okay. Examples. That's a polygon. All right. Another example could look something like this. Right? So that's a polygon. And you can take a hexagon. A hexagon's a polygon. Those are all examples of polygons. All right. Anybody still drawing? Okay. Good to know the names for the number of sides. 3 sides is a triangle, 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 8 sides octagon, 10 sides decagon. Anybody know what 12 sides would be called? Okay, that's a dodecagon. And then anything over 12, you just give a number. So if it had 13 sides, it would be a 13gon. That's what that n-gon means. If it has n sides, it's an n-gon. So if it has 25 sides, it's a 25-gon. Quadrilateral. Quad means 4. So quadrilateral is a 4-sided polygon. Parallel lines. Lines that are in the same plane and do not intersect. So these two lines, they're on the piece of paper, they're in the same plane, right? We show that they're parallel by putting arrows on them, the same number of arrows. Just like we use tick marks to show side length, use arrows to show parallelism. Both have one set of arrows. Both have have a pair of arrows or whatever. As long as they have the same number of arrows, then they're parallel. So we probably would label these lines, and so we could say L parallel to M. Right? Parallel lines. All right. Now, why did we have to say the lines are in the same plane for them to be parallel? Why do they have to be in the same plane? Okay, so my arms are parallel, right? They're in the same plane. They don't cross. They're parallel. Are my arms parallel now? They don't cross. They're not going to cross. Are they parallel? No. So that's why you have to say they're coplanar, because they could be like this. They don't cross, but they're not parallel. What are these lines called like this? Anybody know? Okay, it's the next term. It's skew lines. Skew lines are lines that are non-coplanar. Non-coplanar. Skew lines. That and do not intersect. Non-coplanar and do not intersect. Skew lines. All right. So more definitions. I told you guys this chapter would be a lot of definitions, so here we go. The next definition is square. A square is a quadrilateral in which all sides are congruent and all angles are right angles. Picture of a square with the correct markings I'd put boxes in each corner to show that all the angles are 90, and I'd put tick marks on each side to show the sides are all the same length. That's a picture of a square. Next term. What's a quadrilateral which all angles are right angles? What would I call that? All angles are right angles. Rectangle. Good. Rectangle. All angles are right angles. Rectangle looks like there's a rectangle. Is a square a rectangle? Yes, it is. Next term. What's a quadrilateral in which all sides are congruent? Good, rhombus. It's a rhombus. Some of you remembered. It's a rhombus. So a picture of a rhombus might look like that. Is a square a rhombus? Yes, it meets the definition. All sides are congruent. A square is a rhombus. Is a rhombus a square? Always. No. Is a rectangle a square? Always. No. Okay. Quadrilateral which opposite sides are parallel. Parallelogram. It's a parallelogram. Okay? To show a parallelogram picture, I would have something that looks like that. That's a parallelogram. Okay? What's a quadrilateral in which exactly one pair of sides is parallel? This one's a little bit tougher. Yeah, good. Trapezoid. Trapezoid is one pair of sides is parallel, and so we have, this looks something like that. That's trapezoid. All right, everybody caught up? Just tell me if I'm going too fast. I'll slow down. Just raise your hand or say I'm not ready, and I'll wait. Okay, the next term, isosceles trapezoid, is a trapezoid in which the non-parallel sides are congruent. Looks like that. So the non-parallel sides are the same length. Isosceles trapezoid. Kite, a quadrilateral in which there are two distinct pairs of adjacent sides where the sides in each pair are congruent. What does all that mean? When we do the picture, it'll make more sense. So the kite picture of a kite, something like this. Okay, so I've got two distinct pairs of adjacent sides. So here's one pair, here's the other pair of adjacent sides. I mean, that are congruent. And each pair is congruent, okay? The adjacent sides are congruent. So the sides across from each other aren't congruent, but the sides next to each other, two of the pairs, they're congruent. Okay? Another way you can draw a kite, you could draw it like this. That's a kite, actually called a dart is the name for that type of kite. We don't work with them that much, but that is another type of kite where one of the sides is concave. All right. Next term, reflectional symmetry. Or reflection symmetry, I should say. Reflection symmetry. Reflection symmetry is when there is a line along which a figure can be folded so that one half of the figure matches exactly with the other half. So you can fold, if you fold it over, it's going to overlap exactly. The fold is called the line of symmetry. And or you could call that the axis of symmetry. Everybody got it? Okay. So, how many lines of symmetry does this triangle have? One, right? It would be right here. There's one axis of symmetry here. What about the square? How many axes of symmetry does it have? Yeah, 3. You've got this one. Divide it this way. You can divide it this way. Or you can, oh, I take it back. 4 is correct. There's 4. And then you can divide it diagonally. That's 3. And you can divide it diagonally this way. So it has 4 axes of symmetry. What about this equilateral triangle? How many axes of symmetry? Yeah, it has 3. 1, 2, and 3. All right, what about the scalene triangle? How many axes of symmetry does it have? Yeah, it's none. This would be none. Very good. Okay, now we have another type of symmetry. It's called rotation symmetry. Rotation. Symmetry is when a figure can be rotated about a point less than a full turn so that the image is identical to the original figure. The point is called the center of rotation symmetry. So we take this example here. We've got this equilateral triangle. If I take this point, this original point here, and I rotate it, I can rotate it up to here, and we're in it exactly overlaps the original triangle. We have the exact same figure. Okay, that is you can do that. There are 3 rotations like that in a equilateral triangle. So you take 360 divided by 3, and so its rotational symmetry is 120 degrees. Okay, now you could also, so the definition says that you can rotate it so that it's less than a full rotation. So you could say it has 120 degrees, and then I would also say it has a rotation symmetry of 240 degrees, because if you rotated it 120 twice, you'd be in the same place you were before. So it has rotation symmetries of 120 and 240. Now you wouldn't say 360 because that's the full rotation. Okay. So it has 120 degrees and 240 degrees. All right. Any questions on the notes? No questions on the notes.